we are Accelerate Technologies. We are based in South Cerney, not far from Swindon. So we know the local area extremely well. And the title of our presentation today is a bit of a mouthful, but it's called Secure Cloud Native WAN for the New Normal, why COVID-19 is ushering out traditional WAN topologies and MPLS networks. So quite a bold statement, perhaps quite controversial, but our task over the next sort of 45 minutes or so will be to present to you our argument of why we believe that is the case. But before we do so, just a little bit more about ourselves. I know we had a good introduction from Chris, but I'm Gavin, in case I haven't made that clear, and this is Darran on my left. We've known each other for a long time. We used to work together in South Cerney, on the other side of the road from where we are now, working in the distribution layer in technology, very much in the kind of sort of networking side of things. And we specialised in bringing new disruptive technologies to market, often vendors from the US or elsewhere that wanted a platform to bring these technologies to the UK and Europe. So we would actually work on behalf of a lot of the resellers, consultants, service providers, systems integrators, and we kind of brought the expertise in the particular sort of products and technologies that we represented. They would often bring opportunities to us, and we would do a lot of the work in the background on their behalf. So it would be perhaps presenting the technologies in the first place, designing the solution, doing all the technical sort of scoping and sizing, managing the deployment, actually physically deploying the equipment, sort of project management type services. And then actually for some of these customers, we would build and run managed services on their behalf. So we could deliver the entire package, but we never actually owned that end customer relationship. So sometimes that could be really frustrating for us because we didn't really believe the solution that the partner was proposing was necessarily suitable for that customer and their business. But it wasn't our place to say so because we were acting on behalf of that solutions provider. So it could be quite frustrating for us, and we had many conversations about how we would do things differently if we could actually be that partner and do it ourselves. And eventually, nearly 18 months ago, we actually made that a reality, and we started Accelerate Technologies. So we've got a real passion for technology, a real passion for delivering good, strong customer service. And we've got a wealth of experience from our sort of 10 years working in distribution, and Darran also brings experience from working for vendors and in resellers in the past as well. And what we really want to do is bring something different to the market, where we want to build these really long-term sort of trusted advisor relationships. In order to do that, rather than leading on technology, we really sort of lead on the consultancy side of things, really trying to understand our customers and their business, and then advising on suitable technologies that will actually support them as a business today and help them achieve their future goals. So hopefully that gives you an understanding of who we are and where we've come from, and get on to with the actual subject now. So before we start talking about the technologies that we think are going to potentially replace MPLS, we should probably start with a little bit about why MPLS is actually so popular in the first place. I mean, it has been the connectivity method of choice probably since about the mid-noughties. The reason why it's so popular is it's reliable and it's consistent, particularly when you compare it to just standard internet links. If you try and connect your wide area network using standard internet links and VPN, the internet can be quite unpredictable in terms of the performance, in terms of the latency that you may experience, and it can become very difficult running applications across them, particularly if you're running things like voice or video. So what MPLS gives you is something that's very predictable, very reliable, full nines of availability, very little packet loss. So you really know what you're getting, and your applications as a result will run much more consistently and just better overall. It's backed normally by a telco. You have an SLA, so you know you're going to get this consistent performance and experience. They manage that backbone, so whether you're just within the UK or you're running internationally, you know what you're going to get with an MPLS network, and it's going to be consistent. There are some security benefits as well. So typically, if you're using an MPLS network for your wide area network, you don't enable any direct internet access in your branch offices. Everything comes back over the network to the HQ or data center. So you just have one internet ingress and egress point that you need to secure to keep your wide area network secure. Anything you'd add to that, Darran?
No, I mean, MPLS is a private VPN effectively, and as Gavin said, the exposure to the internet has in the past not been so great, but things are changing. Applications are moving, and obviously we'll talk a little bit more about that in a second.
Exactly. So, everything we said there about MPLS, it sounds great. So you might be wondering, well, what's the problem with MPLS? And I mean, there's nothing wrong with MPLS per se. The issue is that the world has changed, things have changed. And the major contributor to this change in terms of wide area networks over the last sort of 10, 15 years is the cloud. So go back sort of 15 years or so, and we typically have these kind of hub and spoke networks. Our applications lived in the HQ or the data center, and our branch offices were connected in a kind of hub and spoke type design. And that all worked beautifully. You knew where your sites were, they were pretty stationary, and your branch office is, nothing really changes. So we didn't have many people working from home remotely, maybe depending on your industry and the type of organization you are, but typically your remote workers were a small subset, and it was probably kind of, infrequent ad hoc stuff. What the cloud have done to change, or the cloud has done to change this situation, is now our applications, they're not in this nice, centralized headquarters or data center. We've now got applications out in the cloud, and not just in one location necessarily either. We've potentially got software as a service, things like Office 365 or Salesforce CRM systems. We might be using AWS or Azure to host some of our platforms. And when we're accessing these applications, we're not on the MPLS circuit anymore. We're back out just over the standard internet. And we don't necessarily know exactly where this data is and where you're going to access it. So everything that MPLS did to give us that consistency and reliability across the wide area network is great when you're on the MPLS circuit and you're going from branch office to data center, but we don't have that benefit anymore when we're going out to a lot of these cloud applications. We're back to the unpredictable internet, which was the whole reason that we were using MPLS in the first place. So this idea of the core of the network, do we even really have a core anymore, or actually are our applications really spread across a much wider area? And that static network that we were dealing with is now extremely flexible.
Yeah, just one thing to add there as well, we've got the proliferation of mobile devices as well. So more people are using mobile devices today. So again, that just gives you less control over who's accessing your data, how they're accessing those applications, and of course, which networks they're coming across as well.
Yeah, exactly. Because now we are always on. We're at home on our mobile phones, checking emails or doing whatever. It's not a case that once you leave the branch office, you've logged off and you're switched off. You're still connected to the network. So the other thing that cloud did, as well as sort of changing the topology, it also kind of changed the way that we consume IT services. So we've now got this new world of sort of agility, elasticity, scalability, and speed. So applications in the cloud just, the scalability there, you can spin up applications as you need them. You could, feasibly, run off with your credit card and spin up a new application and have it running in an hour. So that's really changed the way that we approach IT. And you can access it from anywhere as well, the nature of the cloud. It's also pushed a lot of the sort of the requirements off to third parties as well. So when we're running a new application, we haven't got to worry about the server hardware. We don't have to worry about refresh cycles of our servers. We've moved all that problem off to the cloud provider. And as far as we're concerned, that actual kind of hardware platform and availability is infinite. And we can consume those services on a more of a subscription usage-based sort of model, rather than that capital expenditure of buying hardware. And then when you're talking about software as a service, I mean, that's even more, there's even more simplicity there. We haven't even got to patch the applications ourselves anymore. That is all handled for us by the providers of that service. And we're now in a world where, when you think of email systems, CRM systems, ERP, document management, whether we're talking Microsoft or any other vendor, it's pretty much all now delivered as software as a service. And I can't imagine an organization now, a greenfield organization that's setting up, that would choose to run any of those applications in-house on their own servers. You would just go to the cloud. That's now become the new norm. And that's the way that we procure and consume IT. So we were already moving in that direction. Cloud has moved us into a scenario where the applications are not on our premises anymore, and changed the way we consume them, and perhaps the way we connect into the network. And then we have to mention the C word. COVID-19 came in March. And although we probably had remote working, home working capabilities, what this meant is, rather than our home working perhaps being a minority of the workforce, it suddenly overnight became the majority. So again, when we were in the branch office, at least we probably were on the MPLS network for at least some of what we were doing. Now when we're going from home, we're potentially completely off the MPLS network. Depends how you've configured your network, how you set up your people to come in. But they're probably coming in through some kind of VPN client to your network. And if they are touching the MPLS network, but they're coming out to the cloud, you're probably not getting much benefit, if any, from that MPLS network whatsoever. In fact, in some cases, depending again on how you set up, that MPLS network could actually be becoming a
bottleneck.
Yeah. Indeed.
And obviously, it's the likelihood is it's going to extend the application away from the user. So we talk about extended latency, and that just compounds the issue with user experience and performance.
Okay. The other sort of result or impact of COVID-19 is, when we all got sent home, we weren't with our colleagues in the office anymore. So it led to this huge uptake in collaboration tools, things like Zoom, Teams, saw massive surges in usage, all running real-time video and voice traffic, which would all work great over an MPLS network. But again, we're at home. We're not on the MPLS network. We're back over standard internet. So as a result, we've seen a lot of organizations that, whilst they've given sort of perhaps workable solutions for work from home, the performance and the security and the visibility is not what we would have experienced if we were in the office. And troubleshooting becomes very difficult for the IT team as well, because the environments that people are working in are all pretty much unique.
Yeah.
So around sort of April, May time, we actually were planning to run a survey out into the markets, looking at SD-WAN and SASE, which are topics we're going to come on to. But given that we were sort of a month or two into lockdown, we thought we should actually ask some questions about COVID-19 as well, and understand how businesses were coping. So this particular question, which was answered by 800 IT professionals out in the UK, from businesses of a reasonable size, or certainly I think it was 500 or more employees and 10 or more sites. We asked them actually what challenges have COVID-19 and work from home actually introduced to your business. So we can see that the top results here are remote worker performance and support issues, issues with maintaining remote worker security and patches, because perhaps you're not picking up those patches you normally do when you're connected to the network in the office, issues with remote worker capacity, abilities to support this increased number of remote home workers, the number of dispersed and unmanaged remote worker devices. Perhaps not everyone who's connecting from home is connecting over corporate devices, issues with capacity and lack of visibility. So this just trying to show here that everything we've spoken about here is not just us guessing. We actually heard this almost from the horse's mouth, so to speak. We then asked people if there were particular projects that they were going to bring forward as a result of the work from home proliferation. And the answers that we got back here were that these particular projects were moving up the chain of priority. So improving visibility and security for remote workers and cloud infrastructure came top, because obviously when people are at home, we actually lose just a bit of that visibility of what people are doing. We're not going through the corporate network and getting all the security sort of features that we have on the network. Obviously reducing management and overhead and cost. I mean, not many businesses have come out of this situation with an increase in revenue. So clearly budget's going to be an issue for people. Improving application performance for cloud hosting applications and software as a service was in there, and improving network agility. And you can read these yourselves, but typically it's dealing with issues that are caused by people working from home off the corporate network and perhaps connecting into applications that are off out into the cloud. So all issues where the MPLS network doesn't necessarily assist. So we've spoken about the benefits of MPLS and why it is such a popular connectivity form. So let's have a little bit of a look at the drawbacks of MPLS in this world now where we're really consuming a lot of our applications from the cloud, and our people are able and actually required to work from anywhere. So number one is this lack of flexibility that you have with MPLS. Everything we've spoken about our cloud is all about flexibility, being able to turn services on and switch them off at the drop of a hat. MPLS is quite the opposite. You want to put in an MPLS circuit, you're typically going to wait weeks, if not months, to actually have that circuit deployed in a new location. If you want to upgrade your circuit, again, you're probably looking at weeks to upgrade the capacity on a link. And you enter into contracts that are typically very long, typically inflexible. And if you decide you want to close a branch office and exit that contract, there are often early termination charges for doing so. If you want to make changes on the network, things like quality of service changes, things like that, they're not in your control. These are all controlled by the provider. So in many ways, it's a benefit because everything's being managed for you and looked after for you. But it's also a drawback because when you want to make changes, you actually have to raise a ticket and go through this system and wait for the provider to apply those changes for you. And then, of course, we've spoken about mobile workers. Now that they're from home, working from home, they're not on the MPLS network. They're not getting the benefits. And as we discussed, potentially could even actually end up hindering performance depending on how your network's set up and how your users are connecting in. Your MPLS isn't connecting you with the cloud services. It's certainly not connecting you to software as a service type applications. You typically don't have this direct internet access at your branch offices and remote sites. So whilst that can be good from a security perspective and managing the traffic coming in and out of the corporate network. Actually, if your users in that branch office are trying to access software as a service, perhaps your Office 365, they've actually got to be backhauled over the MPLS to your data center and out from there to your software as a service application. So you're actually introducing additional latency there and bottlenecks, and probably making performance worse than it would be if they were actually able to go out to the internet directly. But the reason you haven't done so is it would be an additional, firewall or something to manage. But we'll have a look at some of those scenarios as we go. And then we can't ignore as well that MPLS isn't cheap. It is an expensive solution. The cost per megabit compared to standard internet can be 3 times to 10 times more. Once you go international, certain locations around the world, that cost can really be exaggerated and become higher. So anything to add on MPLS there?
Yeah, no, just that, there are many add-on services to MPLS. A lot of the service providers will create these services for you. Gavin talked about connectivity. So your internet connectivity is typically out the data center. And that a lot of the time is to do with the security elements, because the branch office is not geared up to secure direct internet access. So it does just extend that latency. It pushes the application further away, whether it's SaaS, website, whatever traffic that might be. And so MPLS is kind of at the state where you've got this private VPN, but everything else seems to be a bolt-on, doesn't it? It just keeps bolting things on, and it doesn't necessarily solve the problem that we have today.
Okay. So it links on to the next piece very nicely. So the result of sort of where we are today with this proliferation of cloud applications and mobile users out there that are all sort of existing outside of the MPLS network is we've had to move to a lot of point product solutions to solve the connectivity out to the cloud and out to your mobile workers. So we have a bunch of different products here to solve the security aspects of how we connect into the cloud, the performance aspects, how our mobile users actually connect into the network, how the branches connect out to the cloud. So we've got quite a muddle of different solutions that are standalone, probably from different vendors, all require their own sort of management, their own capital outlay, their own management overhead, and it really becomes quite a difficult world to manage. Are you confident that you understand how to use all of these applications? Do you understand all the different vendors' way of working? Are you managing the patches correctly? What do you do when you want to add a new site or a new user? There's a number of different sort of products here that are involved. How do we integrate all of this in the event of a merger or acquisition? It's really sort of created quite a complex network and management and security situation. So we've got a quote here from Gartner. I'm sure you've read it yourself, but it's telling us that digital transformation and adoption of mobile, cloud, and edge deployment models have fundamentally changed network traffic patterns, which renders existing network and security models obsolete. And a further quote here from Gartner. So after decades of focusing on network performance and features, future network innovation will target operational simplicity, automation, reliability, and flexible business models. So clearly the model that we just looked at really doesn't tick these boxes.
Yeah, and I suppose just to add to that, I mean, network and security more network hasn't really kept up with the change that we've seen with cloud. But that I believe is starting to change now.
Okay. So we've set the scene now. We've spoken about the benefits and the drawbacks of MPLS networks. We've discussed the challenges that the way we work now have presented. So we're going to start looking at actually some of the alternatives that we have to help us on this journey to the new world. So we'll have a look at internet-based VPNs. We'll look at SD-WAN. We'll look at this idea of SLA, back supportable backbone, or slabs, and we'll move on to this idea of SASE, secure access service edge. We're going to assume your knowledge in these areas is you've got a basic understanding of some of these terms, but nothing in depth. So hopefully we hit the right level for you. So just before we head into it, I want to have a little look at internet, because internet has changed. When MPLS started becoming a hugely popular service, the internet connectivity that we could typically get, especially outside of the larger cities, was really poor. I mean, I remember 15 years ago when we were supplying solutions like WAN optimization, and perhaps what were the early days of SD-WAN before we knew it was called SD-WAN. Your typical branch office outside of a city, you'd be lucky to get 2 meg. You'd have an option of perhaps an ADSL. Perhaps you could spend a bit more money on a SDSL.
Yeah, leased line type
leased
stuff.
lines.
Yeah.
But still, you were probably lucky to get much more than 2 meg. Now, over the last sort of 5 to 10 years, that amount of bandwidth that we can get has increased massively. Fiber is more typically available, so your download speeds are probably 20 times way more. Places where you used to be stuck on 1 meg, 2 meg, perhaps now through fiber you can actually get yourself as much as a gigabit of download speed. So that definitely helps. You perhaps haven't got those kind of congestion issues that you would have had in the old days, but it is still the internet. So whilst the capacity and download speeds are there, perhaps as a result some of your latency is better than you would have received, it's still the internet. It can still be inconsistent, and you can have a real sort of variability on that the latency, but capacity is there, so perhaps could form a part of our solution.
Yeah, and obviously latency is one of the biggest killers of applications, especially more legacy applications as well, that may not have typically been designed for the WAN. You talk about 4G is more widespread, and again we talk about 5G coming. From what we've seen and what we've heard, early trials of 5G have actually shown that whilst 5G gives more bandwidth, like we talk about fiber, has actually shown right now to introduce more latency. So not quite ready yet from a 5G perspective, but again, these are all sort of internet-based services right now that people are trialing.
Okay.
Great. So so I've got a slide which I just want to run through, which talks about the alternatives, as Gavin suggested. So starting with something that might be very familiar with people is the sort of traditional VPN solution. Secure VPN tunnels between sites using next-gen firewalls. This is ideal for organizations with on-premise applications, possibly hosted in data centers or head offices. But the setup and the configuration is a very static configuration. It's inflexible, and obviously it's prone to security mismatches, human error with regards to security policies and things like that. So, the firewalls over the years have also progressed. We've seen many firewalls integrate new security features, so we can scan for malware, we can detect if there's any intrusion prevention and highlight any anomalies. And again, the firewalls have all got this sort of interlinked URL filtering, so we can restrict, we can monitor where users are actually communicating to. But again, it's all individually configured and managed. You have to log on to them. So your IT teams effectively have got a lot of work to do to keep on top of this. So, again, organizations that required resilience through diverse links, they probably had to settle for this sort of complex design. Again, slow link failover, and also possibly not having the capability of load balancing capabilities as well. So you're putting these dual links in, but not actually benefiting from them. but you know, the internet has is always presented concerns. Gavin talked earlier about latency. You've got this sort of fluctuating network latency, and this could be because many service providers are offering internet connectivity. It could be the path or the distance to the actual internet backbone that you're having to go through, and this will all add this sort of varying latency across the internet. So organizations have started to add in MPLS services to try and get around the extended latency, or maybe the performance not working as they needed. So you've got this sort of more hybrid approach. This gives them the service level guarantees for those latency sensitive applications, or maybe they need quality of service to ensure their voice and video is performing as needed. And so, you know, as we've seen with things like Teams, more people are adopting Teams as a communication method. This is really, really crucial. So MPLS has obviously got a benefit in this case. But like anything, as Gavin suggested 3 to 10 times, service guarantees will always incur an additional cost for that level of infrastructure, and obviously the managed support services that go alongside it as well. Then we added cloud. So those that have decided that, you know, they want to realize the benefits of cloud and they want to migrate applications that are more suited to cloud. But connectivity was still through the form of an SSL VPN or an IPsec VPN. And typically we would set those VPNs up within the data center. And we talked about it earlier. So now we've got this connectivity in the data center to our infrastructure. We've picked the application up and we've moved it further away from the premises. So our users in our branch office have now got to come down through to the data center, and we use the term tromboning to send it straight back into the infrastructure in the cloud. Again, this just adds increased distances and latencies as well. So then we added SaaS. So 365, Google G Suite, whatever those might be, those SaaS applications. And so now we will give the users that sort of access directly into SaaS, but by giving them this access and having these sort of independent firewalls that we have to manage, we've now increased the challenge that the security teams have in monitoring and protecting the data within these new environments. And again, we're all storing a lot more data, and we've lost control, particularly on what kind of data is being stored in here and how it might be shared. All these infrastructures, all these SaaS applications are all about collaboration and allowing us the ability to share data more freely. So that's a huge challenge that we have as well. But we also look at those businesses who decided that that was too much of a security concern to allow direct access. Again, what they might have done is deployed something like a web proxy within the data center and allowed businesses to actually control where users actually communicated through to SaaS or any website traffic and things like that. But again, this just led to further performance issues and obviously user complaints in terms of performance and things like that. So then we had SD-WAN. So SD-WAN kind of brought to market around 2015, so around 5 years ago. We started to see more businesses to deploy SD-WAN. SD-WAN promised a lot. It promised to build higher performing WANs, obviously using lower cost internet circuits, also promising to eliminate many of the issues that we just talked about around traditional VPNs. So some look for it to enable the business to partially or wholly replace more expensive MPLS circuits, especially when you looked at things like international sites, for example. There was a lot of benefits there to actually introduce that. So talk a little bit more around some of the advantages over traditional VPNs. We've got this sort of touchless deployment. You know, we've got this central policy configurations and management. So allows us to bring sites up much quicker or shut sites down in many instances where we need to. We have now this sort of fully meshed VPN tunnel. So instead of having these sort of static single links between our sites, we've got links to every site. So branch office to branch office to data center, and again, branch into infrastructure as a service as well. the cloud infrastructure obviously brings the branch user closer to those infrastructure services, but it also brings it closer to the SaaS applications as well. So by deploying SD-WAN solutions within data centers that might be hosting Microsoft and Google and things like that. And again, it's the route diversity. We talked about the static ability. You couldn't take advantage of the dual links to be able to distribute your traffic over it. This now gives us visibility and really allows us to determine which application we want to send over which link. So we can send our voice and video traffic over one particular link, and we can send our internet traffic or SaaS application traffic over the other one. And never will the two meet unless we have a failure, for example, or we start to see degradation in circuits through latency or jitter and things like that. So many, many advantages that SD-WAN brought, but it doesn't necessarily answer all the concerns that a lot of people will have around, do I migrate my MPLS to internet circuits? I think there are still some cautions that SD-WAN doesn't quite deliver.
Yeah, I think we found that although the marketing was all about replacing your MPLS circuit with SD-WAN, the reality was that people still needed that level of consistency that MPLS gives you. So it was more a common use case was to keep your MPLS circuit, but use SD-WAN just to add some inexpensive internet links to it just to increase capacity. But it wasn't really replacing the MPLS.
No, so they would run their voice and their video over the MPLS, and they'd run all their non-critical applications over the internet. But wasn't really delivering what they needed, was it? So it's kind of giving you this hybrid approach, but it's still keeping the cost within there from the MPLS perspective. So, we talked about, the internet is still unpredictable. You might be able to add this sort of software-defined layer over the top of the internet, but it doesn't deal with the deviations of latency across the internet. And and this is the one thing that's not written enough about, is that deviations in internet latency can be anything from 50 to 100% higher than what the service providers will quote. They'll quote you the best latency figures. They won't quote you what those deviation figures are. So, things like, SD-WAN also potentially offers WAN optimization, but there are varying flavors of WAN optimization and application optimization within all the different solutions. So it's again, what is the solution that you're going to get from that? And again, you've still got numerous appliances that you've now deployed within the branches that still need managing, still need patching, and it all needs patching or controlling or managing through your business, for example.
We've also found that there are a lot of SD-WAN vendors.
Yeah.
I think the latest Gartner report listed 70 or 80 vendors out there. So it's a busy marketplace. And a lot of vendors have really kind of jumped on the SD-WAN bandwagon by sort of procuring other smaller vendors to bolt on to their offering to create something that's SD-WAN. So there may have been more of a networking sort of routing type vendor initially. And so they bought firewall technology. Well, it may have been a firewall vendor, so they bought the routing technology. But what you find often with these acquisitions is the integration isn't ever really fully achieved, and what you end up with is one box that's just running 2 or 3 virtual machines on it that all need managing separately.
And I think, and the same is happening with SASE today. So SASE was coined by Gartner only late last year, was it?
Yeah.
And there's already a lot of activity with a lot of the vendors who are now buying in, or acquiring some businesses to add in the SASE functionality. And we'll talk a little bit more about what SASE is in a second.
Yeah, I guess the other point on SD-WAN here as well is when we looked at our sort of big issue in COVID, one of it was remote workers. Yeah. We haven't really got a solution here on SD-WAN for remote workers, unless you maybe are going to go and stick an SD-WAN edge device in every home office.
Yeah, I talked to a few customers who actually did have SD-WAN. So during COVID, we talked to them, and that was one of their issues. They realized that they'd put in SD-WAN from a branch perspective, but it actually didn't solve any of their problems for their remote users. In fact, what it did is it compounded the issue. So where they'd actually put servers into local branches to provide, data, for example, their users didn't have access to that. and so they had to find sticky blasters to try and deliver that data to their users remotely. So we have started to see some SD-WAN vendors start to implement some remote access solutions, or at least incorporate some features for remote access. But it doesn't answer all the questions around remote access at all. So so we look at how do we address the additional concerns around MPLS and obviously replacing MPLS circuits. We can obviously add 4G services, so that's just some additional things from the SD-WAN side. And again, we talked about active-active configuration, dynamic configuration, path selection as such. So what can we do to help with the replacement of MPLS? And so we look at, basically at the core, we have a sort of a global private backbone. So this is based on MPLS technology, but it's a private backbone with multiple POPs around the world. And each of these POPs are running a converged network and security software stack. So it allows us to do the connectivity from an SSL VPN perspective, but also starts to bring in security as a service as well. So we're bringing security into the edge of the network. So all POPs are interconnected with redundant tier 1 providers. And this is all being set up and governed by a particular vendor. And obviously delivers the SLAs that we're used to with MPLS. So it gives us the levels of latency that we've been used to with MPLS. It gives us the jitter, and obviously it gives us the minimal packet loss that MPLS also brought. But this design effectively allows all the organizations just to concentrate on that last mile internet connectivity. So it's about connecting into the local POP, and then leaving the managed slab, as Gavin suggested earlier, with this SLA-backed backbone to offer that sort of immediate improvement in network quality over the unpredictable public internet. So this kind of starts to answer some of the questions around how we can use internet connectivity but still get the same level of performance. And again, you've got to remember here that this is on top of what SD-WAN delivers on top. So we've also got the visibility of applications. We can see what's going on. We can redirect and dynamically change where applications go over diverse links, for example. But this also extends a little bit further in terms of the security. So this is what makes this very different to a standard SD-WAN solution. Most SD-WAN solutions will have next-gen firewalls, maybe some URL filtering, for example. But this takes it a step further. This is what we talk about security as a service. And it's combining network as a service and security service together to give us this sort of service-backed infrastructure. And that might sound quite familiar with MPLS. It is effectively a network as a service with some kind of backing of SLAs. But now we can suitably challenge MPLS. So we start to see the future of wide area networking by bringing in a lot of the security functionality. So perhaps we're using application traffic optimization through either application optimization or TCP optimization. So we can make sure that cloud and SaaS applications are optimized right from the user right through to this actual SaaS application, for example. Again, we're bringing security that's delivered through a service-driven approach. So instead of having these point products that Gavin suggested earlier, where you might have malware protection within the endpoint client, or maybe you'll have intrusion prevention at the branch office, for example, we start to see that a lot of the security is delivered through inspection of all the packets that go through that particular POP. And this includes SSL traffic. So we're not just inspecting unencrypted traffic, we're also inspecting SSL traffic. So it gives us much more visibility about what's going on. And so it allows us to determine if the threat is present in the traffic. So we're using secure web gateway, so we can restrict where users go to. We're using advanced threat prevention with next-gen anti-malware and intrusion prevention. This is all done at the network layer. And again, as we start to see things like managed endpoint protection and response capabilities with many, many vendors, we can bring this back into the cloud. So again, we can measure that and protect it at the cloud level. But I suppose, the important point here is that, security policies are all centrally located. We're bringing, where we talk about bringing network and security together, we're effectively bringing teams together as well. So no longer have we got the separation with the security team and a separation with the networking team. They effectively have to come together to work together to deliver the best solution. So, you know, this kind of gives us the flexibility. The one last thing to go through as well is the remote users. That's really important, because this is where it really sets itself apart. So we go beyond the sort of physical locations and cloud resources, and we now bring that sort of mobile user into the network. So whether it's Windows, Mac, mobile, so we talk about iOS or Android, for example, those sort of mobile devices that we're all using so much more can now start to be protected. We can start to measure and monitor what communication they're doing through the network, and also what communication to some of the cloud and SaaS infrastructure. But this is also, security is also really important, because we can now introduce advanced security access. So we can check who the user is, where they're logging in from, for example. So we integrate multi-factor authentication, which is really, really important today. Or maybe we'll use single sign-on interlinked with things like Azure AD, or maybe Okta, maybe users of Okta or Google G Suite, for example. So it's really important to make sure that we check who that user is before we bring them into the network. And a lot of remote access solutions today don't have that functionality, or if they do, again, they're having to be managed individually within the data center. So I think from that, I think we can see that the solution delivers a lot more than what typical SD-WAN does. It gives us, you know, the guarantees of delivery of application, but it also gives us that secure remote access that we need right now.
Yeah.
So,
and this is giving us that flexibility and scalability, and all those words we used about the cloud is exactly what this service is delivering. It's consumed on a cloud-based service. Yeah, absolutely. Okay, cool. So it might seem quite daunting how to actually get started with a project like that. I think the point I wanted to make here is it doesn't have to be a forklift change. You don't have to scrap everything you've got today and replace it with this model. You can just choose to add elements of a model like this as and when you need them, and kind of stagger that process over time. You don't have to use them all if you don't want to. I think, again, the cloud-based delivery of this kind of model is you pick and you pay for the features that you need to use and want to use, rather than having to take everything in one hit. But I think, again, for us, it's not a one-size-fits-all either.
No.
The right solution is going to be different for different organizations, depends on, you know, on the geographical locations of your sites and your users. Depends on the type of applications that you use, depends on, you know, what kind of business you are, what services are you providing, and how do you provide them. So yeah, and a lot of businesses are adopting something like this just from the remote access piece. So that could be the starting point for most businesses, is that you want to deliver a scalable but secure remote access. Maybe the future is then when we hopefully get over the COVID situation, is that we start to think about how the branch office might be reutilized again. Yeah. Okay. So I'm conscious we should move on to questions shortly. It's before we do, we've got a couple of documents which we do plan to actually sort of make available to everyone on this presentation, along with our slides from today. But you can also find these on our website. There's a white paper we've produced which talks about perhaps, you know, some of these barriers of moving from MPLS to a cloud native WAN, and how you might approach it. And also the full report, which we sort of alluded to earlier, that we conducted in May, looking at people's opinions on SD-WAN and SASE, and also some of the implications of COVID. So at this point, I think if we go back to Hopin,
that's the one that's shared at the moment,
and stop sharing the presentation, we might stand half a chance of seeing our questions. Hi, Chris.
Hi guys. I think our audience has maybe been a little bit shy today.
Hey.
I did have a question. I'm in a privileged position and I can ask you directly face to face in that I'm hosting it. I was just curious in terms of the dynamics that you sort of seen shifting in the industry over the last kind of 10, 15 years or so. Kind of today, obviously, there's, you know, much bigger chunks of the organizations that you're talking to who have a vested interest in how their networks, connectivity, all that kind of stuff is run. And whereas it probably, you know, 15 years ago, it was just the IT manager and them alone who were looking at this. You know, it's really important today, whether you're an MD, CFO, CEO, whoever it is, that the organization has the right infrastructure in place. Is that changing the conversation from your point of view in terms of going in and talking to those organizations?
Yeah, I mean, it does. I mean, like you say, in the past, it would be pretty much your IT manager, IT director, network manager, and that was kind of, you know, it was their bag rather than now it really is more of a fundamental business decision. And I think the way you choose to go and the way you choose to set up your network connectivity and how your users are able to connect and interact with services will actually probably have a really big impact on how you are able to function as a business. Get it right, and you know, the world's your oyster and you can move in any way you want. But if you get it wrong, it can be very, very restrictive on you as a business. And these aren't things that, you know, you chop and change, you know, on an annual basis. You're probably stuck with it for a number of years. So it has become, I think, a more strategic sort of topic of conversation that involves, you know, more stakeholders from across the business.
Yeah, I think to add to that, I mean, we hear lots about businesses who are trying to transform their business through digital applications. You know, they're trying to change the way their users are fed information. And again, a lot of those sort of transformation projects can be left in a failed state if you don't really understand how the users are communicating with them, what sort of experience they're getting of these new applications. And just so, you know, the infrastructure needs to have better visibility to allow you to make more informed decisions as well. And so we're seeing that quite a lot. And that's not your network manager that's typically asking for that. That's your customer experience manager within the organization who might be requesting that.
And the other thing I was going to ask, you kind of touched upon it at the beginning around the 800 IT managers that you'd surveyed. How are you seeing that security element of it kind of really, I'm imagining, kind of picking up in terms of that conversation when you're talking to those businesses? Again, I'm guessing it must be a massively changing dynamic, just even more so just in the last few months.
Yeah, I mean, definitely. I mean, the threat is there, and the threat is growing from people working from home. I think a lot of those sort of solutions that were put in place are doing a job. I think people are starting to realise they need to be monitoring more to understand what the threat is. If you can't see what's going on, then how you're supposed to protect it, isn't it? So that security is a big part to the networking infrastructure side of things. And you know, we did an event last week, didn't we? We were talking about sort of data security in the home environment. You know, more people are accessing data. People might be printing data out in the home, for example. What are they doing with those printouts? Is that going in the green bin? You know, the recycle bin, for example? This could be sensitive information. And so there is a lot more security conversations happening. And so if, you know, you've got to decide what that needs to be from an infrastructure perspective, as well as a policies and procedures perspective as well.
Sure. Okay, so I'm just double checking again, and I can't see any other questions from our audience. So you must have covered everything exceptionally competently through your presentation. Just to thank you again from a personal perspective, in that, as I said at the start, our intent was very much to get in content experts to talk about their specialisms in their industries, and you guys have really ticked the boxes on that. So a massive thank you from me and the rest of the Tech Swindon team. I'm sure you guys will be available through email if anybody else has any questions at all that they were too scared to put in the chat throughout the presentation. Just to sort of do a little bit of admin, obviously there's a whole week's worth of events that are going on, and I'm just going to do a bit of a shameless plug for some of the others. So we've got forums tomorrow from BCS on AI. We've got A&D delivering content on Rust and Blazor for anyone who's interested, and gallons more stuff if you just go and have a look on the schedule online. So with that, I think that's pretty much it, and we've managed to get to the hour mark as well. So unless there's anything else, Gavin or Darran, that you wanted to add, I think we will leave it there.
Yeah, probably just the one thing I'll add is obviously follow us on LinkedIn, because there's some good stuff coming through regularly that Gavin and I are working on. Try and additional research materials and things like that. So
fantastic! Thank you very much, and thank you very much for our audience for attending as well.